Hey, how's it going? And I just wanted to do a quick follow-up to a video I just did on the merge sort. And this was using an array of tuples, and this was the code that we had developed. And this all seemed to work just fine. But I wanted to go over something interesting in this code. Now, this comparison function that we create, it seems to require a return function of the same type as the elements inside of the function. Right? So if I try to put void in here or something, I'm going to get an error. Like let me just do it. I'll just put in void here. I'll put in void and I'm going to get an error, right? So everything has to match up, right? With the input and the output and all this. I knew it wanted a tuple return, right? So I just had this tuple sitting up here just kind of uninitialized. Well, it's not uninitialized, it's 0 and there's nothing inside of it. And so since it has to have a return. So this is the actual comparison that's going on, right? And then this function is saying it's going to return a tuple. Well, that's not enough of a return for it, right? So I just put in this tuple and that satisfied the requirement. This all works, right? So what's interesting is if we go into the sorting algorithm and we looked, we see right here, it says check the element in the left half array with the element in the right half of the array, uses the compare function passed in as an argument, right? Then it says if compare, and then it's the left element to the right element. Then there's a comparison going on. You'll notice though that in this whole comparison that it's using this part of the function, but interestingly, the output, the return value, isn't being used in any way. It's just literally using the throughput of the function, but not the output. So what's interesting about that is that we're creating a tuple, right? A tuple data type that's an int and a string, and a tuple data type that's an int and a string, and that's one's being called left and one's being called right. And then there's a tuple up here that just has a 0 and nothing in the string, right? So if I were to change this, let's compile and build the verse code here. And let's push those changes. And I want to show you that this works. So it just takes a minute for this to load up. But you know, while I'm here, I want this to stay on the screen a little bit longer because it's just on there for a second. So let's make it stay on there a little bit longer. Okay, so I guess I got to rebuild the code again. So let me build the code again because I just made that change. So I'm going to show you that this works, right? That this sorts through that array of tuples and that everything's correct, right? So, okay, so let's go in here and we'll go start game. And it should say that Jardine is the winner. So see, it all works. And it says the winning player right now is Jardine. And that's correct. That is correct. So now watch this. If I come back in here to the code, and instead of using this as the return, let's just say I use the left, because this is a tuple too. So if I type in left, it accepts it as a valid return. So what do you think will happen? Do you think anything will change? You might think something would change, right? But let's compile and save this. Let's build the verse code. And let's push those changes. And by changing what the return value is, will it affect the sorting algorithm? That's the question. I would think it would, but it actually doesn't. So watch. Start game, and let's see what it does. Look, it still sorts it. The winning player right now is still Jardine, right? So look, let's escape out of there. Let's end the game. Let me escape out of here. Let's go in and change the return value on that to right side. And so what's interesting, what this is telling me is that sorting algorithm doesn't care what the return is. It is just interested. It is just using this. But let's test this again. Let's go back in here. Let's build verse code. So we had this tuple, we had left. Let's push those changes. Now we're using the right tuple, and it doesn't seem to matter. So there's something else going on under the hood, but whatever it is, it doesn't seem to matter what the return is, which is really interesting. So look. What's it going to do? Ah, it's the same thing. The winning player right now is Jordine. So let's go back in here one last time, and let's just change what's in the array. So let's make Wolverine Bro the winner. Give him the highest score at 1,312. And we have right set as the return value, right? That's the output here, right? So let's go in here to Fortnite. Let's build those, build the verse code. So it doesn't seem to matter what the return type, as long as it's of the same type as what's in the array. That's what it seems to be. And so let's go in here, and it should say Wolverine Bro is the winner now if it's working correctly. Start. Let's see what it does. The winning player right now is Wolverine Bro. So anyway, I just thought that that's really interesting about that sorting algorithm, is that it doesn't seem to matter to it what the actual return down here is. It seems like it's just using this. And if you look at the sorting algorithm, you don't see anywhere where anything, you'll see that it's called, like it's taking that function, but there's nowhere here, there's not any return call function output being used anywhere. Like they're not taking the output of the function, they're just taking the throughput of the function, is what I'm saying. There's nothing being done with the output of the function. They're just using the throughput of the function. So as long as it has a return type that matters, it doesn't seem to matter whether it's the left, right, or some other one, as long as it's the same data type. Just some little fine point. I just wanted to show that. I thought it was interesting.